For our next session, I would like to introduce Jenny Ramseyer, Matt Griswold, and Erica Salvaneschi, who will be co-presenting Peering API automation. Jenny is a software engineer at Meta and is coming to us today from Boston. Matt writes code at 20C and is CTO of FullCtl and is coming to us today from the greater Chicago area. Erica is a software engineer at Cloudflare and is coming to us today from England. It is a pleasure to have the three of you with us today. Welcome them to the stage.
Hi, everybody. Oh, good. It's on. OK. So hi, everyone. I'm Jenny from Meta. And here with me today are Erica from Cloudflare and Matt from FullCtl. And we want to talk to you today about Peering API automation, or our proposal for a new standard for how we will automate the handling of peering requests. So as you can probably tell, this is joint work between a couple companies, Meta, FullCtl, Cloudflare, but also AWS and Google. So we're all collaborating on this proposal. All right, so what are we going to talk about today? First off, we'll go through the previous work on the problem, the present state of peering automation, and then our proposed solution to the problem. And then we'll have a demo of our proof of concept and the future work that we have planned for the collaboration. So before, just in case you aren't familiar, peering was coordinated mostly over email. There were multiple emails exchanged per request, and exchanging all of these emails took a lot of time and effort from the humans on both sides of the peering relationship. So what did we do? Well, we automated it. So you may remember some of this from our talk at Nanog 85 back in Montreal, but just in case, right now, if you want to peer with any of the three of us, you can go to our peering portals. On the left, you can see Meta's peering portal at meta.com/peering. On the right, we have Cloudflare at peering.cloudflare.com. And then on the bottom, we have FullCtls at peer.fullctl.com. So at any of these, a human can come to our peering pages, request peering with us through these different automated forms, and then those forms will be processed by each of the companies. But a human still has to come to the form, which brings me to our proposal. So we want to propose a standard API to manage peering requests. So this is a working group between the 5 companies. It was spun up after the Nanog 85 talk on peering automation. And together we've put together a proposal for a new API to coordinate machine-to-machine peering requests. So the goals here are, we want to reduce the human time spent configuring peering. And with that, we also want to improve the network latency because, as you can imagine, the easier it is to peer, the more people will peer, the better the network. Those are the goals of the project. One of the requirements we have is, again, a security requirement. We use PeeringDB OAuth. This is somewhat standard for the different portals already. PeeringDB is an online repository of all of the different peers and their locations. It offers OAuth services. And with those OAuth services, we can say, basically, the human, or in this case, entity requesting peering, is who they say they are and is authorized to transact on the network for which they're requesting peering. So we use that as our sort of initial security check. So over to you, Erica.
It's me. Oh, hello. So our version 0 of our API exposes exactly 4 endpoints. So the 3 at the bottom now are live but return mock data, just to give you an idea of the shape of the data you will get back. So the auth is then the endpoint you'll interact with to log in and sign up with PeeringDB. So the workflow is fairly straightforward. So to begin with, you just make a request to our location endpoints. So this will, you can pass your ASN, you can pass location type, so public and private. So at the sort of beta stage, we'll only be dealing with public sessions. So then you'll make this request, and you see each location is paired up with a PeeringDB IXID. So we'll grab that and use that to compose your session request. So you will add some data to this, such as AE-SENS and obviously IP addresses, make your post, and essentially at the receiving end, there's the peer who will then accept or sadly reject your peering request. It can happen. So a successful reply from our API will give you, amongst other data, a request ID that you see at the bottom. So this is a unique ID that will be associated with the transaction, so to speak. So you can use that and essentially track the status of your request. So you'll make a request. You may choose to query this endpoint periodically, and then you see that in this case, status will show as configured. So this is the case where you probably kicked off your request and you've turned up your side and you're waiting for the peer. So once both sides are up, then the status will show as established to mirror BGP session status. And that's as simple as that, essentially. Just hand. There you go.
Hi. So I'm going to talk a little bit about the future of where we see this going and some of the things that we've left out on purpose. I want to stress that this is a proof of concept. As many of you know, we've been talking about doing something like this since PeeringDB came out with a version 2 API. We've left a lot of things out to stop arguing, bike shedding, et cetera, just try to get the logic flow working before we make it too crazy. We also want to establish definitions of what we're talking about. We've done a lot of that now. I think we're to the point that we're ready for some public input on it, and we'd like to make sure that everybody else can establish the definitions that we set, like a location means an IX, or a location means a facility was one of the first things that we argued about, for example. Another thing that comes up a lot is security concerns. We currently have PeeringDB OAuth. We would like to add some sort of probably RPKI signing. We envision a multi-factor authentication type thing where maybe RPKI can say that you have the authority to use this resource, such as this AS, and PeeringDB OAuth will be who is actually doing that change. There's also the one thing that we've made sure to leave out of the API and protocol is the peering policy is 100% up to the user to do. So that means that when the request comes in, it's up to that network to either approve the request or deny the request. There are a little bit of feedback that we can have in the API, but ultimately that's up to the network to define. And really, you could do that manually on one side. We don't care what your side is doing. Our side will be doing it automatically. Another big thing that always comes up is P&Is. We have left that out of version 1. I guess as I think maybe I missed in the beginning of this is version 0 right now that Erica wrote the server side and we did a client side. We have that working as a proof of concept full circle. Version 1 is what our target goal is IX only. P&I brings up a lot of complications that once you start arguing about who buys the cross connect, who assigns the IPs, who unfilters first, which is something that surprised me that came up as an argument of some networks won't unfilter before the other one does. So one of the things version 2 will add is the P&I and anything else that we can figure to augment on it. I mean, ideally at some point we could get to having this do LOAs, but right now we want to just have IX peers come up. And obviously you cannot have a peering API without a de-peering API. So we're going to have a de-peering automation as well. We still need some work in the query peering status, connection status. A lot of that's there right now. It needs, some work. Again, proof of concept. We need to have private peering parameters defined. Again, back to the definitions thing. So we're definitely looking for feedback on that. A lot of maintenance notifications could go into this as well. That's definitely a down the road thing, keeping it simple. We urge everybody to go check it out, and you can make issues, join the arguments, etc. And we're open for any questions. Thank you.
Hi, thank you very much. This is Marcos from Dekix. Have you heard about the IX API? And if so, how does this initiative align or overlap with the IX API?
Sorry, do you mean the one available at certain IXs to request LOAs and configure cross-connects?
Yeah, exactly.
Yeah. So we do not currently integrate into that because we're doing just the public peering side, but I think that's something that we're looking to explore as we get more into the P&I side of things.
And that also defines how you connect to the IX. This is assuming you have an IX connection. So that's, I think, an important difference.
Tom Strix, random citizen on the internet. Thanks, first of all, for the work on this. Regarding the RPKI side of things, the CyberOps working group in the IETF is currently working on that specific issue, which are, RPKI sign checklists, so RPKI RFCs. The initial proposal for this is the replacement of LOAs, but I think your solution for like the second factor authentication problem that you're trying to solve would fit into this really well.
Yep, thank you.
Hi there, Colin McIntosh, Netflix. Cool stuff. It seems, just from looking at the messages that you showed, that this is pretty geared towards open peering policies. I know you mentioned some additional checks that you can perform behind the scenes, but do you have plans to expand that protocol for more back and forth between peering partners if there's some additional communication or even rejections that could happen, or do you expect that to kind of happen out of band of this system?
Yeah, so we have, this is again just a proof of concept, so we're assuming that everybody agrees on everything. But obviously this is not the real, the real world is not like that. So that's definitely something that we're considering. I don't think we have a strong answer yet, but it's definitely something we're investigating. And if you have ideas about it, please just let us know.
Awesome, thanks.
We're good to go? Yeah, good.
Thank you.